undisturbed or may be subjected to varying degree of deformation, right? So the rocks, it means it also involves the study of the forces which gives rise to these structures. So the rocks after their formation may remain undisturbed or may be subjected to varying degrees of deformation, right? So the geological structures like those are falls, folds, joints, and also fractures. So these are result from deformation of rocks due to forces acting from within the earth. So these geological structures, what are what are that? Folds, falls, joints, and fractures. So these geological structures not only record geological history, but they also help us in understanding the Earth's process and site selection of engineering projects such as dams, tunnels, and power generations, etc. In addition to search for energy sources and valuable mineral deposits also, right? So these geological structures creates beautiful landscapes which may enhance geotourism. In order to study these geological structures, one must go to the field and observe the earth materials and process in their natural setting. Right? So now we're going to definition of the geological structural geology, right? So structural geology deals with what? Study of structures, right? It observed in the rocks which are formed in response to various forces, right? Various forces. So it involves the study of the forces which gives rise to these structures, right? So generally from within the body. So now the term structural is derived from Latin word, that is, what is that? Struere, Struere. So which means to build, right? To build. So now it has been variously defined in two definitions are here. First one is structural geology is the study of the architecture of rocks insofar as it has resulted from deformation. So who is the author of this book? Billings in the year of 1990. Right? And another one is structural geology deals with the geometry, distribution, and also formation of structures. So author of Fossil in 2010. Right? So these geological structures are dynamically produced patterns or arrangement of rock or sediment that result from forces acting within the earth. So these structures yield information about the tectonic forces. Tectonic forces, right? So tectonic forces present in the earth, right? So there, the term tectonic is derived from, that is also Greek word, right? So that is tektos, Tekos, Tektos, tektos. It meaning builder, right? Builder. So tectonics is the study of the forces and motion that result in the rock deformation and structures, right? So these structures ranges from hundreds of kilometers to microscopic scales. So the false, folds, joints, and unconformity, these are the names of some common structures that are studied under this structural geology. Right? Now, what is the importance of this structural geology? So you see here, the structural geologist is an individual practicing structural geology. So the story revealed by structures in rocks is beautiful, fascinating, and interesting. And also it is of prime importance in geological studies also, right? So now the knowledge of structural geology, it helps to unveil very complicated Earth's primary or megastructures and unravel different tectonic episodes and processes through which the Earth has passed. That is the Earth history. So this helps in understanding the tectonic events and their implication in the formation of different natural sculptures, right? Sculptures on the earth. So, and also it helps us in planning for effective and sustainable mining activities. So, this helps us. What is this? This helps means structural geology. So, structural geology helps us in exploring and exploiting the natural resources like building stones, ore mining and groundwater and also oil and gas, right? So there are many types of structures in which the mineral solutions get deposited. Therefore, the geometrical aspects of these structures are very, very important, right? So it is facilitates in selecting suitable sites for major civil engineering projects means like dams, tunnels, other activities, right? And many project sites are changed or even rejected under adverse, depend on which one structural conditions, right? So the knowledge of structural geology, it helps in delineating sites for artificial groundwater recharge and also rainwater harvesting. So now the reasons for the structures in the rocks, that is majority of the structures in the rock develop due to deformational forces of the earth. So these forces are endogenic endogenic forces in nature, and those are also called as tectonic forces, right? Tectonic forces. So now we are going to the relation between structural geology and tectonics, right? So you see here, get acquainted with the relation between this structural geology and tectonics, right? So the structural geology is mainly concerned with the which one? Rock geometry variance. So tectonics deals with the forces and movements responsible for the generation of the rock or geologic structures. So therefore, this both the structural geology and this tectonics, these are responsible for building up, right? Building up the Earth's lithosphere. So we can say that information about the forces acting within the earth. So the objective of this structural geology is to determine and explain the architecture of rocks as observed in different field works, right? So the field observation are supported by laboratory investigations to attain this objective. So these geological structures range in size from how much? Microscopic scale to hundreds of kilometers, right? Now, the basic concepts of the structural geology, some of the basic concepts of this structural geology before we study about various geological are rock structures like faults, folds, joints, unconformities, right? So the study of structural geology is mainly accomplished with the study of geological structures, so which are developed due to deformation, right? So they are also known as deformational structures or secondary structures. And also primary structures, those are formed as the result of the process it connected with the deposition of sediments, right? Deposition of sediments, they are also known as depositional structures such as bedding planes, right? Or sedimentary beds. Okay. So the structural geologist play a significant role in the identification of the geological structures, their geometry and orientation, the time and sequence of the deposition. So they also assess the physical conditions responsible for the development of these structures. Now let us read this primary geological structure, sedimentary bedding and features like fossils and crystalline compositional layering and also mineral foliation in crystalline rocks. These are the some of the pictures. Now, outcrop. These common terminologies used in some of in this structural geology. Outcrop. You see here outcrop. Okay. Outcrop means they are exposure. You see here, when a portion of the rock appears at the surface, it is termed as outcrop. The term outcrop means what emerges out. Thus, an outcrop denotes the area over which rock mass crops out and it is visible on the surface. So now they are exposure of rocks on the surface of earth, right? So if the rocks are not exposed on the surface of the earth, they are referred to as incore, right? This one, incore. So the outcrops are generally visible along valley walls and rivers or nala section, and also mountains or road or railway cuttings and tunnels. Hence, an outcrop denotes area on surface of the earth over which a rock mass is exposed. The line of intersection of the limiting surface of rock mass with surface of ground mass, its limit, right? So the study of geological structures is generally carried by the study of these outcrops, right? Now you see layering, it is developed in rocks due to the what is the reason? Due to the deposition of sediments and rock materials or minerals, right? So the a deposition of sediments one over another in a basin results in layered or this sedimentary rocks, right? So what is the bed? You see here bed. This is called bed. Bed means bed is a defined as an individual layer or strata of a sedimentary rock, right? So you see these are the layers, right? Green color is one layer and yellow is one layer. So red is another and light yellow is another. So these are some of the layers. These are called beds, right? So each bed is separated by the adjacent bed by a plane that is called, what is that? That is called this bedding plane. Okay? Bedding plane. So if the individual layers are less than 1 centimeters, right? Less than 1 centimeter thickness, they are called lamination. Okay? Lamination. How much? That is 1 centimeter thickness. You see here, this one. Okay? So the process of deposition of sediments in a layer by layer fashion, that is known as stratification. Okay? Stratification. Stratification. Okay? So you see, this figure, a total figure is stratification with numerous beds, bedding planes, and lamination, right? So this is called stratification. So the bedding planes are found in sedimentary rocks, where in sedimentary rocks. So the layering is developed. Layering is developed in volcanic rocks because of flow of lava, right? Flow of lava. So it is also referred as you see here primary foliation. This is called primary foliation because these are developed simultaneously with formation of the rock. So another one is secondary foliation. This is called secondary foliation. It is used for layers found in metamorphic rocks. Metamorphic rocks. These are the igneous rocks, right? Igneous rocks. So primary foliation developed simultaneously with formation of the rock, right? And secondary foliation is used for layers found in metamorphic rocks, right? So the layers in metamorphic rocks develop as a result of the development of new minerals and reorientation of mineral particles from pre-existing rocks during the process of metamorphism. Process of metamorphism and stay cleavage, cystosity, nesosity, etc. So fall in this category of the secondary foliation. Which one? Slatic cleavage and cystosity and nesosity. So these are the fall in this secondary foliation category, right? So now you see, intrusion also. Intrusion. INTRUSIO. What is the intrusion? Intrusion means in igneous bodies, it can be extrusive or intrusive, right? So the intrusive rocks are those igneous rocks which penetrate or intrude in a pre-existing rock, right? So they might have consolidated either at great depth or at shallow depth. So in many times, the layering seen in the intrusive igneous rocks, which can be observed in parallelism with the surrounding this country rocks, right? Country rocks. So that is also called as host rock, right? But sometimes igneous bodies it cut across the beds of the country rock, and because of their late entry into the system along some joints or fractures, right? So we will see here. You can see here, these are the some of the primary foliation and also secondary foliation ranks, right? So now deformation means deformation. Deformation. So this term applied for a process in which the um, original rock, right? Original rock is modified. So the original rock body is usually undeformed and it can be modified by folding, jointing, faulting, or under the effect of gravity, right? So now you see there are three types of deformation that are caused mainly by the horizontal movements of the lithospheric plates it relative to one another. So first one is what is that? Tensional forces, right? Tensional. First one is tensional forces, right? Forces. So what are these tensional forces? So these are stretch and pull rock masses apart. And second one is com compressive, compressive, compressive forces. So these are squeeze and shorten rock masses. And third one is shearing forces. So these are push two parts of rock masses in opposite direction, right? Opposite direction. Okay. So if a rock mass is subjected to directed force for a short period of time, it usually undergoes through these three stages of deformation, right? So initially, the deformation is elastic, and on withdrawal of stress of the body, it returns to its original form. So the limiting stress that is called elastic limit. What is that? Elastic limit. Elastic. Elastic. Elastic limit. Okay. And the deformation is plastic. Plastic. Plastic means when the stress exceeds the elastic limit, that is the body only partially return to its original shape even if the stress is withdrawn, right? So now when there is a stress continuously increased, one or more fracture, it develops and the body eventually fails by rupture. Okay, rupture. It's called rupture. So, in ductile and brittle, these are two commonly used terms by the structural geologist, right? This brittle deformation related to this fracturing of the rock, and ductile deformation indicates bending, stretching, folding, and thinning of rocks and realizing of grains. Okay. So these are the layering and intrusion and deformation. Now we are going to important thing is strike and dip or dip and strike. So now initially strike and dip. Okay. So strike and dip. So these are two references that are important for defining the attitude of any geological feature, right? So the strike and this dip geology, it define the deposition of the structures with respect to a this horizontal, right? Horizontal plane and both together provide a more accurate structural description rather than only strike geology, right? So strike and dip are explained, you see here, one by one. So now you see first one strike. Okay, this one strike. So strike, the strike is the direction of the which one line representing the intersection. You see here intersection between a fault bed or any planar feature and a horizontal plane. On a geological map, this strike line is given by the short straight line segment that is oriented parallel to the strike line. So the strike is given as either a quadrant compass that bearing the strike line, right? So for example, now you can take north 25 degrees east, and in terms of east or west of true or north, right? So a single three-digit number representing the azimuth, right? Azimuth in which is usually the lower number is given usually, or the azimuth number is followed by the degree sign. For example, you see north 25 degrees east will be from 0 to 5 degrees. Okay, 0 to 5 degrees. So this is the strike. Okay, now dip. This is the dip. Okay, dip is the steepest angle. Okay, steepest angle of descent of a tilted bed or a future that is relative to the this horizontal plane, and it is given by the number of degrees. Example 0 to 90 degrees, right? And a letter means north or south, east or west. Okay, so with rough direction in which the bed dips downward. So another technique is to take the strike which makes a dip 90 degrees to the right of the strike. Okay. So when this method is used for representation, the redundant letter. So that follows the dip angle is emitted according to the right hand rule. In geology explains. So in the map, the symbol is a short line that is attached and is at a right angle to the strike symbol pointing in the direction where the planar this surface is dipping down, right? So the strike line and the dip of a plane that describes the attitude relative to a this horizontal plane and vertical plane, it perpendicular to the strike line or strike line, right? So initially, the sedimentary rocks are deposited of flat or gently inclined surfaces, right? So the post-depositional deformation is caused by the movements due to this tectonic, right? I already told about this tectonic forces. Tectonic forces acting on rock body or mass, which causes the tilting of the beds. So what is the strike? What is the strike? Strike means it is the geographical direction of a line produced by intersection, right? Intersection between which one? Inclined layers and a horizontal layers and inclined layer. Horizontal plane and inclined layer, right? That is called strike. And dip is, it is defined. It is defined as inclination. Okay? Inclination. It means angle, right? Inclination of the bedding plane with respect to horizontal. Okay? So it is measured in a vertical plane lying at right angles to the strike of the which one? Bedding. So these are the definition of the dip and strike. Now, dip are of two types, right? So now what is the direction of dip? Direction of dip means it is the geographical direction along which a bed has maximum slope, right? So now you see what is the amount of dip means it is the angle which what is that which varies from how much 0 to how much 0 to 90 degrees according to the inclination of bed. Okay, inclination of bed. So horizontal angle of dip is 0 means no dip here, right? So inclined are tilted. Inclined are tilted. That is angle of dip varying between how much? 0 to 90 degrees. And vertical angle of dip means 90 degrees. Okay? 90 degrees. So dip is the vector quantity as it has both direction and amount. So amount of dip denotes the angle of the bed inclination with respect to the horizontal. And strike is a scalar quantity because it has only direction and no magnitude, right? So strike of the bed is independent of its amount of dip, right? Amount of dip. Now you see here are dip are two types. So those are first one is true dip and second one is apparent dip. Okay. What is the true dip? The maximum amount of dip of a bed is found along a line perpendicular to the strike. It is called true dip. So the true dip direction and strike of bedding plane are always perpendicular to each other. So that means the maximum amount of inclination or slope of bed along a line perpendicular to the strike. That is the maximum slope with respect to the horizon. That is called true dip, right? And apparent dip. The dip of the bed measured in any other direction than that of true dip, it is referred as apparent dip. The apparent dip amount of a bed becomes zero of measured in the direction of strike, even though in reality the bedding plane is tilted. So it means the dip of the bed measured in any direction other than that of true dip, right? That of this true dip. That is called apparent dip, right? So the amount of apparent dip is always less than amount of true dip. Okay? Amount of apparent dip is always less than amount of true dip. Okay. So this is called true dip and apparent dip. You see here, no, the amount of apparent dip is always less than of true dip. Okay, I already wrote here. No, don't worry. Now, what is the relation between this dip and strike? What is that? So the direction of dip and the strike of any inclined or tilted bed must lie at right angles to each other. Thus, this true dip is in the direction perpendicular to strike. Okay, perpendicular to strike. Mm, while mentioning the attitude of any inclined bed, dip amount, and dip and strike direction should be mentioned. Okay. So now what is the importance of the strike and dip? Um, it means first one is the determination of the younger bed or formation. In these geological formations of the older rocks, the deposit um, at the base, which is superimposed by the younger rocks, right? Hence, in a tilted rock sequence, when we move in the direction of dip, then relatively beds of younger age, it will be encountered and vice versa, right? And also another one is classification of geological structures. Those are dip and strike data. It provides useful information in the classification of rock or geological structures. Okay. You see here. So we have read that many rocks that shows planar structures, right? In the form of bedic plane or foliation in any outcrop, right? In any outcrop. So they are not always this horizontal. It may show inclination of varying amounts. So we have discussed that strike and dip slide, right? In that layer in an outcrop. So now let us recall that strike is the compass, right? Compass direction, okay? Of a line formed by the intersection of a rock layer surface with horizontal surface. Whereas dip, whereas the dip means the dip is measured at right angles to the strike, right? Right angles to the strike, and it is simply the amount of tilting, or in other words the angle at which the rock layer is inclined from the horizontal. So the amount of dip of a bedding plane varies. So in order to understand the attitude and orientation of the rock structures, you are required to measure their dip and strike on the outcrops during the field work. And the measurement is done with the help of which one? Clinometer compass. Okay, this is called clinometer compass. This is the real picture. Okay, so the clinometer compass consists of compass and clinometer. Okay, compass and clinometer. So the compass has a circular dial. You see here, circular dial, which is anti-clockwise. Okay, this is anti-clockwise, graduated with how much? 360 divisions. Okay. You see here, count this one. Okay. 360 Okay. 360 divisions in the outermost circle for reading this direction. So this circle is called azimuthal circle. A Z A Z I M U T H A L azimuthal circle. So where that is you see here 0, right? 0 to 360 here. 0 to 360 represents for north, east, west, north, sorry, east, west, north, south, right? You see here. So 0 or 360 degrees, this is represent where? Which place? In north. And 90 for east here. Okay? And 180 for south. And 270 for west. So it has a magnetic needle, this one, this black color. This magnetic needle which rests in north-south, right? North-south direction of the earth when set free, okay? So the desired direction is read on the dial with help of north. It marked end of this magnetic needle. So one of the inner circles on the dial that is also marked with directions such as east. You see here, okay? You see here, this one, okay? East, northeast, northeast, west, etc. Right? In supplement to the outermost circle to read the direction directly. Okay? So the inclination of a line with respect to horizontal, that is read with the help of this clinometer fitted in compass. So it has a frame with open space within the clinometer frame, which allows seeing one of the this inner circle, right? Inner circles in the dial marked with 0 to 90 degrees graduation. So the reading of inclination, it means dip amount, so which may be variable between horizontal, that is 0 degree, to vertical, it means 90 degrees, that is measured with the help of a mark in the middle of the this frame opening. Okay, so the bridge fitted outside the dial, it helps in taking reading of the inclination of bed. So the bridge is movable, which can rotate up to 90 degrees, right? 90-degree angles from a plane parallel to the dial up to a plane perpendicular to the dial. Okay. The bridge line is always parallel to the which one? North to south line. North to south line of the dial. So the locking device is present outside the dial ring, which on pressing locks the magnetic needle, this one, as well as clinometer, so that the reading may be noted even after removing the compass from outcrop. Okay, so this is the real photo. This is the photograph of this clinometer compass. So So now, how to measuring strike and dip of an inclined bed? Inclined bed. Inclined means like this. Okay. So anticline is syncline. This means inclined. Okay. So now that is to measure the strike direction, the place the compass on bedding plane in, so that the bridge of the compass touches the this bedding plane, right? Bedding plane completely. Okay. So then rotate this compass so as to ensure that the bridge becomes horizontal and one end of the bridge it still touches the bedding plane. So now let the magnetic needle, this black color needle, it move freely. Let the needle come to rest and then read both ends of the this azimuthal circle which represent strike, right? In order to measure the amount of diff of the bed, draw a line on the bed perpendicular to the strike and keep the bridge on the bedding plane along this line in such a way that the dial plane is vertical. The reading in clinometer, it gives the amount of dip. Okay. So in order to measure the direction of the dip, what is the direction of the dip? That is, place the bridge along the line drawn on the bedding plane so that the dial face, that is the sky. Which side? Sky. So then rotate the compass to horizontal so that the bridge and north-south line of the dial both remain parallel to the line. So the crown is often marked as north. So take care the crown in the dial, it towards the dip direction of the bed. So on rotation of this clinometer to the horizontal, right? Horizontal, the north marked end of the magnetic needle, it gives the dip direction. Okay? Dip direction. So now the time you can check your reading. So the true dip and strike direction are always which place perpendicular to each other. Perpendicular to each other. So now some societal benefits of studying this structural geology. Those are the crust of the earth is structurally very complicated, right? So it has undergone many modifications in this geological time scale. So the study of structural geology, it enables our understanding in unrevealing the mysteries of our earth crust. So now, and also it is important for planning mining plants activities and also exploration, mapping, and also exploitation of the earth resources depend on careful interpretations of this structural, those structural geological geologists and artificial groundwater recharge also those projects also and rainwater harvesting techniques, um, those required study of these structural features of the geological terrain, right? And selection of engineering site projects and depend on its structural settings, right? The sites are even changed or rejected due to adverse structural settings. So it is said civilizations exist with geological consent and ancient civilizations existed along the river valleys which usually flow along major geological structures. Now, we're going to rock structures. Rock structures. So those are broadly divided into three types. First one is planar, Planar, planar structures. And second one is linear structures. And third one is folds and falls. So first, you see one by one. So what is planar structures? Planar structures are those structures which are found as a plane or as a surface in the rocks. Okay. So the planar structures go hand in hand with linear structures. So in this, we have major planar structure types is there. First one is bedding plane. Bedding plane. I already told about this bedding plane. So they are the planes that bound a sedimentary bed. A bedding plane separates. What is that? Bedding plane separates. You see here this one. Bedding planes. A bedding plane separates the two beds in a sedimentary rock, right? And next one is metamorphic foliation. It means it is a planar structure which is formed during deformation and metamorphism of pre-existing rock. So they are characteristic feature found in the metamorphic rocks such as slate, gneiss, and also schist. And next one is igneous foliation. They are absorbed with igneous rocks, and those are also known as primary foliation. And fault plane is a fracture along which the rock blocks have been displaced. Okay, you see this picture. Okay, displaced. So now bedding plane means they are the planes that bound a sedimentary bed. A bedding plane separates the two beds in a sedimentary rock, right? Now, fault plane is a fracture along which the rock blocks have been displaced. So now we are going to giants. Giants means they are irregular or regular planar separated portion found in the rocks. So giants are the fracture surfaces along which movement is negligible, not observable. So they are among the most common of all these geological features. So the systematic study of these giants in an area, it can unravel the timing and sequence of its formation, right? The cooling of lava or magma, it can produce giants in the rocks. And also fractures and giants, those are among the most important things in geological structures. It considered in hydrology and also engineering geology and also some of the mining projects, right? Now you see here, this is the rhombohedral giants. You see, these are the, okay. Now linear structures. It means as the name just that structures is line-like features observed in this rock. You see here, mineral lineation. It means if the longer dimensions, you see here, longer dimensions of the minerals are aligned in a particular direction. So you see here, this particular direction, it gives rise to mineral lineation. Okay. Now, crenulation, lineation. So they form when any planar surface such as foliation is affected by folding on small or microscopic scales, so that hinge lines, these lines, okay? These hinge lines of these folds are aligned in a particular directions. This is called crenulation lineation. Okay, you see here, this is called crenulation, and up is crenulation and down is lineation. And also last one is um, folds and falls. Okay? Folds, folds and falls. So what is the difference between folds and falls? Now you see, folds means folds are combination, right? Combination of planar and linear structures, right? So you can imagine folds in rocks are like folds in clothing, our clothings. Daily you can observe in your daily routine clothes, folding clothes, right? It similarly, when the layers of rocks suffer gradually compression by the tectonic forces, right? Tectonic forces in the crust, they are pushed into folds. That's called folds. So the layers of rock can be crumpled or buckled into folds. And folding can be defined as the bending of rock strata due to compressional forces acting and tangentially or horizontally towards a common point, right? Towards a common point or plane from the opposite side. Okay. So we can define a fold as the wave-like undulation, wherein the bending or arching of the rock layers takes place due to forces of the which one? Earth. Okay. So the folding is a common form of deformation. It displayed in the layered rock. And folds are best displayed by stratified formations like sedimentary rocks or volcanic rocks or metamorphic rocks, right? So folds vary in size from how much centimeter on outcrop scale to hundreds of kilometers on the regional scale, right? Now, what are the importance of this folding? Folding, the study of the folds in geological studies, that is important because of the reasons means folding exposes the deep-seated rocks on the surface of the earth, and also it increases the mineral deposits because of repetition of layers due to folding in a limited area, and it facilitate development of site for deposition of mineral bearing solution, and folds serve as a good host for oil and natural gas. These are the importance of this folding. Now, um, parts of folds. You see here. So now you see different parts or elements of fold means the wavelength of fold, it can be defined as the minimum distance between its two successive points, right? Two successive. Two successive points of same phase. So alternatively, it can also be explained as the distance between these two alternating inflection points, right? So you see here, this is the eye, these are the points, right? And you see difference. So part of a fold, this one, right? So here. W. W means wavelength. So this A means amplitude. This H means hinge point, right? I means inflection point. Okay. So, and crust is the highest point in the profile section of this fold, right? You see here, like this one. Okay. So this crest, it's called crest. So crest is the highest point in the profile section of the fold. And you see another one. So this is called trough, Trough, trough. So it is the lowest point in the profile section of the fold. Okay. So crustal line means that is the highest located line in the fold. It can be obtained by joining the crustal points in a folder layer. And trough line means that is obtained by joining this the trough points of a folder layer. So this line is located the lowest in the fold. So cumulation means that is the highest point located on the crystal line. And depression is the lowest point located on the trough line. Okay. So now these are the folds. So I think class is time is up. So I will take the class and tomorrow. Now session is completed.